and today I'm going to be talking about React State Management. Specifically, what I'm looking to accomplish in this is I'm not looking to just go over any given solution or tell you this is the best solution. In fact, I'm trying to suggest against thinking in that way. Rather, what I'm hoping to empower you to do with this presentation is have an understanding of how a lot of state management solutions are implemented and be able to make informed architectural decisions about which state management solution is right for various use cases in the apps that you are going to be building. Also, there is a repository to go along with this presentation. I've posted it in the engineering channel. So if you want to follow along with the code, or if you want to have access to these various solutions in general for your own reference, it is at my GitHub, and it is under React-State-Management. There's 4 projects in there. You can run npm install to install the dependencies, and then npm start will run them. Just to show you exactly what that looks like, we are building this, a pirate tic-tac-toe game, and we are building this game with 3 different React State Management solutions. So what's running right now is the very first one, which I'll go over shortly. All right, so continuing on, I'm going to talk about what our goal is. I'm going to give you an overview of what model view intent architecture is, then talk about component state plus the React Context API, Redux, and then general recommendations for making decisions about architecture. So first, let's talk about our goal. So anybody can write code, but the job of the software engineer, at least as I think about it, is the management of complexity. And here's a list of people way smarter than I am who've more or less articulated the same thing. I'm particularly a fan of Kent Beck, who said simplicity is the most intensely intellectual of the XP values. That refers to extreme programming. But anyway, what exactly do we mean by complexity and simplicity? My favorite book on software engineering is called A Philosophy of Software Design by John Ousterhout. And he defines it as follows. Complexity is anything related to the structure of a software system that makes it hard to understand and modify. So when I think of complexity, I tend to break it into 3, perhaps a few more competing concerns. One is local complexity. How difficult is it to comprehend the code that is right in front of you in the file? System complexity is how difficult it is to understand how all of the various components of your system interact with one another into the combined whole. And then performance isn't exactly complexity, but it is another factor that you need to be taking into account, and it is how quickly and efficiently the computer itself can process your code's operations. Now, very often you need to make trade-offs between these. You will improve your system complexity, but make an individual file more difficult to read. You might improve performance, but it's going to be more difficult for engineers to understand how it is your system is running. So these are the trade-offs you need to make and evaluate depending on your use case and your company's needs. Now, there's no silver bullet here, like Fred Brooks said in a famous paper in the 70s. There's no universally right answer. No matter how much marketing is put behind any given state management solution, no single one of them is going to be right for every single thing you're going to be building or every single application that you're going to be doing inside of that project. So you need to evaluate what solution is right for any given thing and evaluate the trade-offs to make the best choice you can. So that all having been said, let's talk about MVI architecture. Now, there's many different types of architectures that you've probably heard about in web development. Probably the most famous is Model View Controller, but there's also Model View View Model, Model View Presenter. But we are using React, and the architecture that React is built around is what is called Model View Intent architecture. Now, Model View Intent is what is known as a finite state machine. And a finite state machine is basically, you can think of it as a function that involves a bundle of state. And every time you modify this state, it deterministically returns a new value coming out of that state. And it has the following constraints. It has a fixed set of states it can be in. It can only be in one state at a time. It has a sequence of inputs that are put into the machine. And it has a set of transitions for every state, and every transition is associated with an input pointing to a state. Now, that's a lot to absorb. It's easier to understand in the context of React. So let's break that down a little bit. So the model, or what we tend to think of as state, is the source of truth for the application. This is the data that we have that is driving what our web app is displaying to the user. So if you're familiar with React, you're probably familiar with state in a class component, or the use state hook inside of a function. That is basically, for that component, your model. So you can think of model as a plain old JavaScript object in which we are storing data. The view is the user interface that is being generated for your web app. You can generally think of this as your JSX or your HTML. So when you are generating a view, you are accepting a model into a function, and based on the data that is in your state of that model, you are generating a view that you are displaying to your user. And then the intent is everything that interacts with and alters the model. This can be a timer that increases your state value by 1. This can be a user clicking on a button that causes something to change. This can be a returned call from your backend API, right? So you have an intent that modifies the model, and this generates a new view on your screen. And this is how React works. This process, I'll actually show you this picture right here briefly. You have your model. It is being modified by an intent, generating a new view. The user uses that view to interact with it, generating a new intent, and so on. So this is the cycle that is the core of React architecture. Now, one thing I want to mention is that models are immutable. So when you're modifying a model, you're never just like updating a key value pair inside of an object. What you are doing is you are cloning your entire model, making updates to that clone, and then returning that entire new cloned object to the view and generating a view from that. And this is why whenever you are updating your state in React, you are forced to use this.setState, or the set function in your hook. If you ever fail to use that function, it's not going to re-render the application and generate a new view. And so what the user is seeing is not going to reflect your updated state. And this is why you're not supposed to do that. You are violating the finite state machine pattern if you do that. So that's important for the next point I'm going to make, which is that the only data appropriate for storing in state is that which the changing of which should generate a new view. So what I mean by that is that any value that you are not expecting to drive changes to your user interface, so things like environment variables, static variables, things that you're just keeping track of to reference, but not like to actually drive changes in your app, these should not be stored in state. And if you store them in state, it has the potential to be a bad thing, especially if they're changing, because then you're going to have inappropriate re-renders that could eventually harm performance or something along those lines. It also gives bad information to your programmers who are maintaining the code in the future. It suggests that you're expecting these values to be relevant to view generation, so what's being displayed on screen when it's not. So if you have things that are just static or that aren't related to generating new views, you should be storing these in local storage, use ref, a class variable, and things like that. And then on the flip side, if it is something that you are expecting to be driving updates to the view, it must be stored in state. So you should not be storing these things in local storage, etc., because then you will be violating the finite state machine pattern. One other distinction I want to make, some developers draw a distinction between UI state, which is state changed by user interaction, and server state, which is data received from external endpoints. In terms of like computer science standpoint, this isn't necessarily that important a distinction to make. But React Query, for example, specializes in managing server state. They're not particularly concerned with managing UI state related changes. So that is a paradigm that's out there just to be aware of when evaluating state management. You could have multiple different things that you're thinking about in terms of state management. There's not necessarily one umbrella solution for everything that you're ever going to do. All right, let's talk about the simplest of our state management solutions in this presentation, which is component state. So component state is locally the simplest of the three options. It stores state on the React.component object itself, and it can be accessed in a class component via this.state and updated via this.setState. the state can be passed to children via props, and these props are immutable. You cannot change them. Props can be static values and functions, including state setting functions. In terms of architecture, component state is comparable to the useState hook, which achieves a similar end but stores its data object in a global variable rather than storing it locally on the component object. So let's switch over to a code demo. So we are just rendering essentially Pirate Tic-Tac-Toe is going to be our highest level component. And as you can see in here, we are setting a default state of game board, which is empty board. This is just the game board. I don't want to get too much into my implementation of tic-tac-toe, but it's basically a matrix, just an array of arrays, and those arrays all contain just strings that are values in the board. We have our winner, we have our player, we have our number of X wins, and we have our number of O wins. So inside of our top level parent component here, we have a function called takeTurn. And basically this is accepting an action, and the action just consists of which row and which square the action was taken in, the click was taken in. It is itself keeping track of which player's turn it is, and it is altering the player with every single action that is taken in takeTurn. And it is evaluating whether or not we are in a winning state for the person who is playing. And then once it's made all of these evaluations, it sets the state and updates the game board. It updates the player, the winner, and so on after every single iteration. We also have a reset game function that does basically just resets us to our initial state right here. So the important thing to mention here is that in order for any of our child components to get access to this state, we need to pass it down to them in props. So for example, game square is our lowest level. This is literally a single square. And we have passed it from Pirate Tic-Tac-Toe down into game board. And then game board has taken onTakeTurn and passed onTakeTurn down into game square. And then game square knows which row and square it is in because game board has told it so in its map function right here. And then on click, it simply calls onTakeTurn with the row and square value of itself, passes those things all the way back up to our takeTurn function, and the takeTurn function handles it. Now, I have put a little console.log of render right here, and you can see, if I open this, that every single time I do a click, this top-level component is re-rendering. So this is the simplest solution, but let's talk about some of the pros and cons of this solution. So the pros, locally simplest solution. Anybody who is familiar with React will have a pretty good idea of how this is working. It is also very easy to unit test. If you want to do a unit test of a given component, you're basically just mocking out the props and making sure that they're called as expected. If you want to do an integration test with the highest level components, you don't need to do any special shenanigans. All you're doing is rendering the component with React Testing Library or Enzyme or something like that, and just making sure that when you click around, it behaves as you're expecting it to behave. So very, very simple, easy to unit test, easy to understand. But here are the cons. The data sharing between components can only be achieved via a parent-child relationship. And this can lead to a great deal of complexity if data is needed by distantly related components. So for example, if we had a significantly more complex app than what we have right here, perhaps we have multiple branches of components that are being rendered in completely different parts. Maybe we have user data that needs to be shared globally. Maybe we have just some single piece of data that's stored, that's affected primarily in one section of the app, but is needed one time in some other part of the app. Then you need to hoist that data all the way up to the lowest common parents between those sections of the application. And then that parent needs to be responsible for all of that. And then every single time that bit of data is going to be updated, all of the children that are beneath that parent are going to be re-rendered. And that can potentially cause performance problems. You can mitigate this to a degree with React.memo. However, ideally, we would like to avoid adding additional memory consumption and spending computer resources compensating for a problem that is, in truth, a design problem. Can we improve our design rather than relying on additional processing power to manage it? So that's where this is at. So by default, I would say, generally speaking, you should start with component state API, but sometimes that's not going to be right. So let's talk about a potential solution if you have a more global state concern. So I'm going to talk about combining the component state API with what's called the React Context API. And what we're going to be doing is we're going to be building a pattern called the observer pattern. The observer pattern is a subscription pattern that allows an object to subscribe to an event and be notified when that event occurs. It consists of three components: the subject, the observer, and the concerned objects. The subject is the central store that runs everything. It just is storing the state inside of it. The observer is a list of functions relating to the objects that are interested in the state changes inside of the subject. And then the objects are just the things that will be updated when changes inside of the subject's state occur. And this can be a very powerful tool when you have many distantly related objects that are interested in state changes in a common store of data. So this is just some pseudocode. It's very similar to JavaScript, but essentially inside of our subject, we're going to have a subscribe function that is going to push the function that is passed into the subscribe function into a list of observers. Likewise, our unsubscribe function is just going to pull whatever we want to unsubscribe out of there. And then the fire function, all it's going to do is it's going to fire all of the functions that are inside of our observers array. And generally speaking, in our case, we're actually going to be passing something into those functions. We're going to be passing the updated state down to all of these observers. So this might be a little bit abstract, so let's make it a little bit more concrete by talking about this implementation in React. So React Context was added to serve as a means of managing global data. It is not itself a state management solution, but rather it is a mechanism through which you can communicate data from one component to another component without having a direct parent-child relationship. There's a whole ton of libraries that use the Context API. If you use styled components, they've made great use of it. And in fact, pretty much every single state management solution these days uses the Context API to some degree. In fact, even including Redux now. That wasn't always the case, but now that Context API exists, even Redux uses it. So components can subscribe to the context provider that we create with context.consumer, the use context hook, or by setting context type inside of the class component. So let's talk about our React observer pattern. So in our case, we are going to create a subject, which is going to be a stateful React component that renders a provider and all of the children that are passed into it. Our observers, or rather the array that we are using to hold all of our observers, is going to be our React Context API. And our objects are going to be all of our components subscribing to our context. So let's make a little code demo now and show you exactly what I mean by this. So this is our component state, and this is going to be our context API. So at the top of app.js, I have added an app provider. And what this app provider is this is essentially very, very similar to what we had in our previous component state, except instead of keeping it at the highest level parent, I am keeping it inside of this other component called app provider. Once again, it has its own internal state. It has a take turn and a reset game function. These functions are exactly the same as we previously saw, but this right here is the magic. We are now creating a React context provider, and we're setting the value that we are passing into this provider equal to the state inside of this component. And we're also passing down on take turn, or rather this on take turn and reset game. And then we're receiving children and props. All we're just doing is we are passively rendering children beneath this context provider right here. And I've also written this other function here that all this is doing is it's creating a higher order component that for any component that is passed into with app context, it is going to wrap an app context consumer around it and inject the values provided by the provider into the props of that component. Now that you can achieve the exact same thing, or rather something very similar, using the use context hook, or using the other setting the context value on your class component. I'm doing this because this is the initial implementation of it. This is the old school way of doing it and the simplest implementation with as little additional layers of abstraction on top of it, including hooks and so on. So I'm figuring, understand this, you are understanding React context in its purest form. So let's talk about an implementation of this. So here we have GameSquare. And remember that previously on GameSquare, we had to pass everything from the top level components through the parent and then down into this, right? Well, instead, what we can do here is we can wrap GameSquare with app context. And by doing that, GameSquare is now subscribing directly to our app context provider and receiving on-take turn from it. So if I were to go to GameBoard, GameBoard is not passing on take turn down into GameSquare. GameSquare is getting it from this context provider. So every time we do an on take turn, an on click right here, it is updating the values inside of our context provider instead of updating the entire app context. And the consequences of this can be pretty cool. So previously I was running component states, but if I instead boot up the context API, you'll see that we had our first initial app render here, but every time I click, the entire app is no longer re-rendering. All we are re-rendering is the GameSquare and every other component that is subscribed to our context. So as a result of this, you can achieve a significantly better performance outcome. And let's actually talk about that in the pros and cons of the presentation here. So the pros of this, you're able to provide global state management in a surgical way. Only those components concerned with a set of state will be re-rendered when it changes. This is already built into React. You don't need to add in any additional libraries. You don't have any additional liabilities from that. And there's no hidden logic or magic. This is a clever solution, but anyone who understands React should be able to look at this and know exactly how it is working. The cons are that this is more locally complex than using component state and just passing down props. It is going to become more difficult to test. You're going to need to have, if you're going to do an integration test, you're going to need to have a provider inside of your test, or else you're going to need to mock out whichever mechanism that you're using to have your components subscribe to the context. It's a little bit more mentally abstract. I think anybody who understands functional programming at all can sort of understand, yeah, I understand how functions are just passing props down to other functions. This one, you need to have a sort of abstract understanding of, okay, I am subscribing to this observer pattern and it is forcing updates through a higher order component. You need a deeper understanding to understand this. So it is more complex, but still simpler than a lot of other solutions that are out there, at least in my opinion. I do want to issue a few warnings about this particular style of state management, though. A lot of engineers that I've taught this to, as soon as they learn this technique, they want to do everything with this. They get this idea that prop drilling is this intrinsic evil, and I have found this new technique to do like surgical updates on only the components that I want. You probably don't need to do that unless you are really having performance problems and you need to apply that level of like surgical precision to everything. Prop drilling is probably going to be fine. And the trade-off that you're making between the local complexity and the abstract thinking that engineers will need to make to maintain your code are probably not worth the minute changes in things that of performance that you're getting from not having to re-render parents quite so frequently. So if you have a parent-child relationship, just use the parent-child relationship. You don't need to create a context. You only need to create a context when you have a legitimately global state management situation that you need to share across distantly related components. And the other thing I'll say is that use more than one context. Very often, a lot of people who discover this, especially people with Redux experience, who are familiar with using like one global state storage, they discover this. It's like, oh, this is built into React. I'm going to do all of my state management inside of this one context provider. But what you need to keep in mind is that when you update the state in this context provider, it is going to update the state of everything that is subscribed to it, which may or may not be relevant to the change that you made. If I make an update to a payment, I don't necessarily need my delivery addresses to re-render, right? So if I had a context provider for each of those, I wouldn't want to use the same context provider for that. I would want to have my different context providers for different domains of responsibility. So that way, only those components that are actually concerned with that state are re-rendering when you perform an action that forces a state update. So try and think of that. It's okay to have many context providers, and prop drilling isn't evil. It's just a pain in the butt. All right. So moving on, React Redux, perhaps the most popular state management system out there, for better or for worse. Let's talk about it. So React Redux makes use of what is known as the flux pattern. The flux pattern has some similarities and some differences from the observer pattern we just discussed. The pattern breaks things into 4 parts: the store, the dispatcher, the view, and actions and action creators. Now, if you're familiar with the concept of a publish-subscribe model, it is a variation on that. So let's talk about the store. The store manages the state, both the domain state and the UI state. It's thought of to like maintain all of the state that you're going to be concerned with in your application. State is the value of the data itself. It is being stored inside of the store. The store is the object with methods inside of it that manipulates the state. Like we were talking about with model view intent architecture, the store is a state machine. So there are no setter methods on it. You cannot directly change any values inside of the state inside of your store. You need to update them by passing actions to a dispatcher, which is what we're going to talk about shortly. The store listens for actions from the dispatcher and has logic to decide how to handle those actions. And usually this is a switch statement. And when the store has made a change, it will emit a change event that will inform everything that is subscribed to the relevant state that has changed. So let's talk about a dispatcher. The dispatcher is an object that broadcasts actions and events to registered stores. So these are the things that are responsible for making updates to your store. When an action comes into the dispatcher, it will pass that action to the registered stores associated with what the dispatcher believes they're associated to be. I know this is a little bit complex. Think of it like when we were doing the observer pattern, it was very dumb. I got a state update. I tell all of my subscribers that I've gotten a state update, and they all just trigger their thing, right? Very, very simple. When we're doing the flux pattern, it is the flux pattern is smarter, right? It has these dispatchers that intelligently know how to, like, I am going to inform the store what types of updates are being made, and then the store is going to be making updates appropriately to the subscribers that are concerned with the type of update that has been made. If you are already familiar with React Redux, the role of the dispatcher is being fulfilled by what Redux calls reducers. Next is the view. You're already familiar with the view. It is the user interface. It is the thing that is re-rendering when updates to the store state occur. And the view, like, it has intents, right? User interactions that generate intents. Intents and actions are pretty analogous to one another when comparing these paradigms. So the actions are being produced by users interacting with the view, and these actions are sent to dispatchers, and the dispatchers update the store state. And then the last part is the actions. These are simple objects that contain all the necessary information to perform that action. They have a type property that indicates what type of action that they are. So that way the dispatcher and the store can collaborate in deciding what needs to be updated in the publish-subscribe model. And then actions can, of course, come from views. They can come from initializing the app. They can come from timers. They can come from backend calls, all sorts of different places. These, like I said, these are analogous to the intent. So here's a little illustration. So user clicks on deposit. That goes to the event handler. A dispatch sends the action over to the store. The reducer handles that action, updates the state, and then the state updates the UI via the fact that the consumers of that state are subscribed to that particular state change as determined by the reducer. This is a mouthful, obviously. It takes a fair bit of time to really wrap your head around how all of this works. I'm going to show you some code now, but appreciate that this is indeed a difficult concept to grok, and probably more than I can talk about just right now. Oh, I guess I have a few more things to say. I'm pretty sure I've explained all of this. The only thing that's on here that I'll mention is that you might have multiple reducers, but Redux will combine all of those reducers into a single reducer in the combine reducers function. So ultimately, you're only going to have one reducer. But anyway, let's move on, and I'm going to show you an implementation with Redux. So this is the exact same thing as we had before. This is Pirate Tic-Tac-Toe. And Pirate Tic-Tac-Toe, you'll notice that we have a fair number more files here. So I want to show you, this is our game state reducer. Now, you can usually have many different reducers, and you'll see we have this combine reducers function inside of our reducers index. This combine reducers is going to accept all of our reducers and combine them into one. And then inside of our top level components, we are going to have a provider that is going to create a store and pass into it a reducer and our initial state, which you can see right here. Our initial state is exactly the same as it has been with every other application we've done so far. So the reducer, we only have one reducer for this app, but our reducer this is going to have a lot of the logic that we had before, but it's going to be organized in a slightly different way. And you can see that it is organized according to the type of action that is going to be passed in to the reducer. So if we produce an action, and I'll just show you what our action types are right here. We have two action types. We have a take turn action and a reset game action. And our take turn action, all it's going to do is it's going to pass to the reducer the relevant row and the square, just like it was doing previously, except this time our reducer is going to accept that, recognize it as a take turn, and run all of the logic appropriate to taking a turn, just like it was in our previous implementation. And what it's going to do is this reducer is going to return an updated state. And this updated state is going to be consumed by our store, which is being generated in our, where did my index go? Inside of our create store function right here. So in the stratosphere, there is a store that is keeping track of all of this. And in React Redux, the way that you subscribe to this store is through the connect function. And I will show you in Pirate Tic-Tac-Toe, from React Redux, we are importing this connect function. And what this connect function is doing is it is accepting two functions, map state to props and map dispatch to props. Map state to props is taking the store that has been registered in the provider at the top level of the component, and it's saying, okay, store that has all of this state, give me the following state values. I am going to take these state values, and I am going to create a higher order component and inject these into the props of the components that I am wrapping, which in this case is Pirate Tic-Tac-Toe. What map dispatch to props does is it's doing the exact same thing, except it is taking the potential action types and creating dispatchers for those action types. And those dispatchers are going to map to what we have set up in the reducers, and those reducers are going to process them in exactly the way that we just described. So just to illustrate that a little bit for you, I am going to stop this one right here. I'm going to go over to Redux, and I'm going to boot this one up. So I have console logged out the props that we are currently receiving inside of our Pirate Tic-Tac-Toe game. And you can see that we are receiving the 3 bits of state that we have subscribed to in Pirate Tic-Tac-Toe and map state to props. And we are also receiving the 2 action types that we have subscribed to via map dispatch to props. And then once we have access to those inside of those props, we can pass those down to child components. We can call them here. We can do whatever we like. Now, in principle, I could have done map dispatch to props down here all the way in GameSquare and simply use the props that are being injected in there to put those into the onClick here and directly update the Redux store from GameSquare rather than passing it down through props and Pirate Tic-Tac-Toe, and thus achieve a similar re-rendering performance enhancement that we achieved with the Context API. There's a debate in the React Redux community about what the proper way to implement state subscriptions in this manner are. There are those who feel that you should have state isolated to as few components as possible. You should have them just in high-level parent components like this, and then you should pass any functions down to children, and those child components will then therefore be pure functions that behave entirely deterministically and get all of the test ease and functional programming benefits associated with that. There are also those who think, no, why would you do that? You have a global state management solution for a reason. Those things that require access to state, simply subscribe to them in the ways that are available to subscribe to them. You don't need to have this parent-child relationship. I'm not entirely sure which is right. There are advantages and disadvantages to each path. You will just need to evaluate this as well as you can when you are faced with those situations. Okay, so going back to the presentation, I've gone over that. So let's talk about the pros of Redux. It is a means of supplying global state across the entire app in an, in principle, efficient and elegant way. It has an excellent capacity to implement surgical state subscriptions, if you want to go that way. And components need only subscribe to the state with which they are directly concerned. And the code can be meaningfully divided up to make these divisions of responsibility clear. React Redux in particular has some additional bells and whistles. It's easy to persist stuff to local storage if you want to do that. You can pre-fill things from a server very easily. You can create snapshots of state. And perhaps most interestingly, you can maintain an undo history and time travel across state changes in your app. Now let's talk about some cons. Of the state management solutions that I have shared with you, this is the hardest one to understand and the hardest one to responsibly manage. It can take developers a significant amount of time to recognize how the web of state is organized across the application, competently update it. You could add something that's updating a piece of state to one component without being aware of how it is affecting another distantly related component in the application. And this can cause bugs that you had no idea about because it's very difficult to write tests that are going to properly guarantee that changes that you make to a global state aren't affecting other things in that global state. React Redux also encourages and almost requires splitting actions, reducers, and components across many different files. So if you're doing something as simple as like checking whether you have a modal open or closed being stored inside of React Redux, you're going to need to create like 4 different files just for doing that. Versus if you're just using the use state hook, you can do it all inside of the components right in front of you. And this dependence on global state can systematically harm the modularity of your app and make unit testing extremely difficult. There's a lot of really common anti-patterns with React Redux. One very common one is that people just start connecting every single component. You don't need to do that. Just because you're using Redux for global state management doesn't mean you have to use only Redux for all of your state management. Just like we did with the Context API, you can have React Redux for your global state management and use component state for your local state management. And in my opinion, generally speaking, you probably should. It's also important to realize that not everything needs all state. When you are mapping state to props and so on, make sure that you're only subscribing to the things that are actually concerning the components that you are building out. If it's not concerned with some distantly related state, don't bring it in. You're just creating liabilities for your component and making it more difficult to test. And perhaps most importantly, if you are building a component that is designed to be reusable in many different locations, you should do everything you can to try and make that a purely functional component. You should not be connecting this because the moment that you connect it to global states, you have burdened it with a particular context in which it is meant to perform. It's no longer reusable. So try and keep reusable components pure. Do not subscribe them to your global state management system. So let's talk about general recommendations. Use component state by default. You're not going to undermine the company you work for by using component state. All the engineers are going to understand it. The worst thing that's going to happen is you're going to have it be somewhat suboptimal. It's going to have some performance problems. That's the worst case scenario. You're not going to wind up with an application that you simply cannot make updates to because nobody understands the massive conglomeration web of state that you have constructed yourself. So by default, start with component state. And if it is a local state concern, if you are just checking whether a modal is open or closed, you should probably be using component states to keep track of that. When to use components in context. If you have a global state that may update and it's going to be, the state is going to be consumed by many distantly related components. Component plus context is a very good way to solve that problem. Some examples: user profile information, shopping cart contents, things like that. This is my opinion. 99% of the apps that you build can probably be solved, but state management can probably be solved by nothing but these two solutions. You probably don't need to bring in an additional library unless that additional library is providing bells and whistles that are unique to your particular use case. But if all you need is state management, if all you need is just a place to be storing data and forcing re-renders across your app, the stuff that's built into React is probably enough. When to use Redux. You have a great need to not only maintain global state, and this is necessarily global state, not because it's just because of whatever, but also because you need a lot of the other benefits of using the flux pattern. You get the time travel. You get a great deal of information about how your user interacts with your app. So for example, if you are a social media company whose entire value proposition involves tracking every single action that your users take and delivering tailored ads based on that tracked user behavior, Redux is excellent for you. And it's understandable why Facebook would invent a tool like Redux for their use case. Or alternatively, if you really need time travel, if you really want to have that extensive undo history and you want to be storing that inside of your state management, Redux is very good for that. Pete Hunt, I have a quote of him saying, if you aren't sure you need Redux, you don't need it. Dan Abramov, developer at Facebook, React, Redux developer, don't use Redux unless you have problems with vanilla React. Personally, I've worked on many applications that have used Redux. In my opinion, not a single one of them has needed it, and it's always caused more problems than it was worth. But that's my anecdote. Here is one tweet involving Dan Abramov. I pity the poor junior dev who was forced to use Redux because management read that Dan Abramov said it was the right way to handle state, but it makes no sense to them and they were let go for not being productive enough. Dan Abramov, that's literally the reason I'm going to hell. So what about favorite state management library? There are so many of these. I have not worked with all of these. I cannot give you details about every single one of them. The overwhelming majority of them are using either the observer pattern or the flux pattern to do their state management. If you are considering one of these, what I would ask you to consider is, does React's native state management serve my state management needs? Can I get the bells and whistles that this thing is providing me through another mechanism and use React's native stuff? Because generally speaking, that's going to be simpler. However, sometimes it is going to be better. For example, we are using GraphQL. And so it's there's a lot of really easy interfacing with GraphQL that is available to us through React Query. That is perhaps a compelling reason to use React Query for our particular use case if it accelerates us in that way. But whenever you're considering bringing in a state management library, just ask yourself, what is this buying me? What is this getting me over and above the natively available things that I have inside of vanilla React, which they've done a lot of work to make a robust state management solution available just in vanilla. So what is the simplest solution? what does my team understand? Are they going to need to learn another layer of abstraction in order to understand this library we're bringing in? If I have a particular design pattern that this library depends on, how am I going to guarantee that design pattern is implemented despite turnover, despite potential lapse of understanding with new people joining the team, and so on? Like, be careful about documentation, be careful about documenting what design decisions are, why you made the decisions you did, and hopefully it will work out well. That is what I would recommend when bringing in these outside libraries. So here's my bibliography. This entire presentation is available on the GitHub repo, so please help yourself to any of the articles here. Dale Alleshouse is my mentor. He originally developed this many years ago. I have been maintaining it and improving it ever since. But you can check out his repo, Rating React, there. He talks about MobX, he talks about unstated, and a few other things in there if you are interested. So that is my presentation. Thank you all very much for coming, and I will stop presenting now.